problem number 6. Okay, so an electron, which has mass 9.11 times 10 to the negative 31 kilograms, moving near an atomic nucleus, has a speed of 6 times 10 to the 6 plus or minus 1% meters per second. What is the uncertainty in its position? Now, when you hear something like uncertainty in position or uncertainty in speed, you know that it's going to be a Heisenberg uncertainty principle problem. And we actually only have one equation for that in the whole course, which simplifies things a bit. The equation is delta x, which is uncertainty in position, times m delta u, which is uncertainty in speed, is greater than or equal to h over 4 pi. And for questions like this, we want like the minimum uncertainty. So it's okay to use equals. Now remember, these don't refer to speed and position, they refer to uncertainty in speed and uncertainty in position. Okay? So they told us the mass of the electron. Mass, it was 9.11 times 10 to the negative 31 kilograms. Okay? And they also said that, they also mentioned that the speed was, which is u, equals 6 times 10 to the 6 meters per second, plus or minus 1%. Now, like I mentioned, it's not the speed that we're interested in for this equation, it's this plus or minus 1%, because they're talking about the uncertainty of the speed. So, all you need is, you just need to figure out what 1% of that is. You can divide it by 100 or however you do that. But that makes the uncertainty in u 6 times 10 to the 4 meters per second. Okay? So now you have your delta u, you have your m, h is a constant, and obviously 4 pi is a constant. So you can rearrange this equation algebraically, and that'll give you delta x, which is what we want, the uncertainty in the position, is equal to h over 4 pi times m times delta u. Okay? So we'll just plug in those values. It's best to use a calculator for this. So this is 6.626 times 10 to the negative 34 joules times seconds. That's Planck's constant, h, over 4 pi the mass is 9.11 times 10 to the negative 31 kilograms. And delta u is what I said before, 6 times 10 to the 4 meters per second. And now, because of the true units of joules, everything is going to end up canceling out except for one of the meters, which is what we wanted because we wanted an uncertainty in a position which is measured in meters. So this is going to work out to 9.65 times 10 to the negative 10 meters. And at first glance, it might not look like that's one of the answer choices, but this is actually really, really close to 1 times 10 to the negative 9 meters. And that's answer choice A on the test.